Hey, it's Mr. Redstone, and in this video we're going to be solving some multi-step equations. Now to solve all of these, and I'm going to keep them relatively straightforward as this is an introductory video, I'm going to use the acronym DCI. That's going to get us through all of the equations in this unit. It stands for distribute, then combine or collect your like terms, and then use inverse operations. We are going to do all of our equations using those three steps. So in this first example, I don't even have any brackets, so I don't have to use the distributive property. However, I do have some like terms. I see I've got a negative 2a and I've got a positive 4a. Those can be combined. Negative 2 plus 4 would give you 2a's. Plus 3 equals negative 3. So I can't do anything more on the left. Those are unlike terms, so I'm going to use inverse operations. The inverse of adding 3 is to subtract 3, so I do it to both sides. 2a is negative 6. And now I can do this step in my head, but the inverse operation of multiplication is division. Negative 6 divided by 2 is negative 3. Next example, again I've got some like terms. 2b and minus 11b, those can be combined to get negative 9b. Subtract 4 equals 5. And I'm left with a two-step equation. The inverse operation of subtracting 4 is to add 4. And whatever you do on one side of the equation, you do it to the right. Negative 9b equals 9. The inverse operation of multiplication by negative 9 is to divide by negative 9. b will equal negative 1. And if you were to substitute that into the equation, you would see it makes the left equal the right-hand side. So next up, we're going to throw some parentheses in there. So we go back to our acronym of DCI, and the first thing we're going to want to do is distribute. Now that's not the only way we could have attacked this problem, but it's a safe way to do it. Negative 2 times 3c is negative 6c, and negative 2 times 4 is negative 8. I use inverse operations to get rid of that subtract 8 by adding 8 to the left side and the right side. Leaves me with negative 6c is 12, and you can probably do this in your head. You divide both sides by negative 6 because that's the inverse operation of multiplication. c is going to equal negative 2. Next up, don't let the fraction scare you. 1/2 of 6d is 3d. 1/2 of 2 is 1. And the fact that the variable's on the right, please don't let that throw you off either. It doesn't matter if it's on the left or the right. So the inverse operation of adding 1 is to subtract 1, and I do it to both sides. 9 is 3d, and we can do that in our head. We divide both sides by 3 to get d equals 3. And now I'm going to do one more pair of examples with you. But this time I've got variables on both sides of the equal sign. So again, we're going to DCI this. And in this first example, you see that there are no terms that we can distribute. But some might think that we've got some like terms. So I'm going to draw this line down the equal sign. That's a great barrier. Nothing crosses that. You look at the left, you see 16e's. You look at the right, you have 5e's. Those don't combine. You combine what's on each side of the equal sign. So the inverse operation of adding 5e would be to subtract 5e. And if you do it on one side, you do it to both. And what you're left with is 11e is 22, or e equals 2. Last example. This time we're going to use the letter D. We distribute 7 groups of f plus 7 would be 7f's plus 49. And on the right-hand side, we have 5f plus 59. Now those are unlike terms on both sides of the equal, so we can't combine those. So what we're going to have to do is take care of the variables on one of the sides. Personal preference, I always like to get rid of the smaller quantity of the variable. So the inverse operation of adding 5f would be to subtract 5f's, and you do it to both sides. 2f plus 49 is 59. We subtract 49 from each side, and we'll get 2f is 10. And that's pretty trivial at this point. We divide both sides by 2 to get f equals 5. And that's it for this video. Thank you very much for watching. See you next time.